Welcome to the SmartCrete CRC webinar discussing the Decarbonisation Pathways document. Today we're going to be joined by Dr. Martin Schneider and Dr. Christoph Muller from VDZ, the authors of the report. They will be making a presentation. At the end of it, we're having a conversation that will be moderated by Dax Bawaja and Zoe Schmidt of SmartCrete. So thank you for taking your time today. What I thought I'd do right at the beginning is acknowledge the work that went into the report and thank everyone that was involved. It was an intense time over 3 or 4 months, but the report that actually came out was well worth the effort that was put into it. And as CEO of SmartCrete, I'm proud that we were associated with it. So what I thought we would do is just have a short introduction, as I said. We will just go through a quick update of SmartCrete. We will have the presentation finish off with the conversation. At the beginning, I'd also like to thank our partners in the project, Race for 2030 CRC and the Cement Industry Federation. So please, could you all mute your call into the webinar using the mute button? Questions will be welcome throughout the presentation, and please submit them using the Q&A button at the bottom of your screen. The questions will be answered during the conversation at the conclusion of the presentations. We're recording this webinar and it will be available through our website from the 6th of December. Also, copies of the presentations that you'll see today will be available through the SmartCrete website again from the 6th of December. Just a quick snapshot of where we're up to. SmartCrete has now been operational for 17 months, and it's been quite an eventful 17 months for those of us that have been involved in it. We, at the moment, have 47 partners and are actively recruiting more to come and join us. At this point in time, we have 17.5 million in partner cash contributions. Our grant agreement requires us to reach 19 million or thereabouts by the end of the year. We have $45 million in partner in-kind contributions, both through staff and also through materials for the projects. As you know, we have 3 research streams: asset management, engineering solutions, and sustainability. And this particular project forms the basis of our sustainability research stream. We've got an active project pipeline. We have 7 projects underway. We have 3 projects at the project agreement stage ready for signature. We have 4 more projects conditionally approved. 7 projects are moving through our approval process, and we were looking at 4 more just this afternoon. So we've got quite a few coming through, and you'll be seeing announcements on our funding of those projects over the next few months. So I'd just like to introduce our speakers for today. Dr. Martin Schneider is the Chief Executive of VDZ since the 1st of January 2000. He has a background in physics and started his career in the cement industry in 1991 in the field of environment and sustainability. He was head of VDZ's Department of Environmental Technology and later was assigned as the head of the Department of Cement Chemistry. Being the head of VDZ for 20 years, he has further developed that organisation into a knowledge centre of the cement and concrete industry, providing services for the whole construction value chain. Martin not only heads up VDZ with its 200 experts in Düsseldorf, but also serves as a strategic advisor for many cement companies around the world. In 2003, Martin was also assigned Managing Director of ECRA, the European Cement Research Academy. ECRA is a platform in which this European cement industry and its stakeholders supports, organises and undertakes research activities within the context of the production of cement and its application in concrete. Its main activities today are on carbon capture as well as future grinding technologies. Christoph Müller is the head of the Concrete Technology Department at VDZ. He has studies of civil engineering at the Technical University in Aachen, a research associate at the Institute of Building Materials Research of the RWTH Aachen, and in the year 2000 was awarded a PhD at RWTH Aachen. In 2000, Christoph joined VDZ. He has a focus on concrete technology in particular, the durability of concrete, that is steel corrosion, freeze-thaw resistance, and alkali silica reaction. He is a member of numerous national and international standardization committees of concrete construction. Since 2007, he has been the head of the Concrete Technology Department. Since 2012, the Managing Director of VDZ Technology, and since 2014, appointed Honorary Professor by Ruhr-Universität in Bochum. So you can see from those impressive CVs that the quality of the research and the input to our decarbonisations document has come through from some very knowledgeable authors. So at this point, I'll pass over to Martin Schneider, and the presentation can commence.
Well, thank you so much, Warren, for this very kind introduction. And it's really a pleasure for us to be with you this morning, or this afternoon, I should say. And I've also have to say that were fantastic months that we were working on these pathways for the Australian cement and concrete sector. And Warren, you have said that we have written the report, but I should say we have more compiled it, because it's all information that we have been gathering through many workshops and meetings that we had with all the stakeholders along the value chain. So thank you so much for supporting this, but also thank you so much for facilitating this important project, because you have not only financially supported with your partners this report, but also the many discussions that we had were very fruitful. And you will see, of course, when we talk about the results today, that they are, of course, coming from all these discussions that we had with you. Super. Okay. So this is the presentation of the decarbonisation pathways for the Australian cement and concrete sector. And of course, taking into account you as an audience, with such a broad scope and covering the whole value chain, we try to focus on a few items here which are important to underline, what the pathways really mean for the sector. The full report, of course, is available. It has been published recently, and it's available to all of you. And it's on the CIF website, for example, but it's available to all of you. So please use the link that is on the last slide, as you will see, to make sure that you have access to it for further details. Now it's all in the climate policy context that was basically, and I think we can all feel this, initiated a couple of years ago. I mean, the climate change is known for many years, but I think we all can feel that something has changed with the climate treaty, the Paris Agreement, some 5 years ago. I will not go into the details because you know this better than me, but I think it's important to underline that this this Paris conference of the party was kind of a turning point, and we could see even in our sector that something has happened, and we could see and feel that the whole value chain for cement and concrete, has put a much stronger focus on CO2 mitigating along the value chain with the target, to contribute to limit global warming to not only 2 degrees, as you all know, meanwhile it's 1.5 degrees. And I think it's also important to feel this sensing, that we are all part of this exercise. For the first time, it is clear that not only one single sector can do this, so that the whole value chain, like in our case, the whole cement, concrete, and construction value chain is involved. And I think it's a great feeling to be part of this journey. And I'm not sure how you feel it. I think it's even a privilege to be part of this transformation. It's probably the biggest transformation in our sector. And if you at the end of the presentation, you look back and you ask yourself, what are the pathways? You will see, all these measures are, of course, they are difficult, to implement, and the engagement plans still have to come. But I mean, on the other side, it's clear that it's doable. We have to work together, and it's doable to implement all these pathways to become, as we say, net zero by 2020, and to really contribute to what the Paris Agreement said, to carbon neutrality by 2050. Now, you all know that has been put in a more concrete context in Glasgow very recently. Again, I will not go into the details here, but there's an implementation plan that has been set into, has to be set now into the national implementation plans as well. And that there are still debates on which direction exactly to go, but the main focus is clear, and this also affects, of course, our sector. And I'm really happy that Glasgow really has opened up some new opportunities, some visibility also for our sector. Now, when we talk about our sector, it's the first time that we have an issue here, and I mean, seen from the cement and concrete side, which we cannot deal with only ourselves. The whole sector is affected. Of course, we all know that cement itself, by its production, I will come to this on my next slide, is responsible for 6 to 7% of the global CO2 emissions. But if you look at the whole construction value chain, it's much more, because for example, not only setting up the buildings and the infrastructures, but also to operating the buildings, takes a lot of energy and consequently CO2. So I think one way or the other, we all are affected by this major target that we are aiming for, to be net zero and CO2 wise in 2050 as a sector, and that means globally. And of course, the question is how can that be put into practice? And it's clear that can only be put into practice regionally, because all the regions have different prerequisites. The situation is difficult, although of course cement and concrete is basically the same material all over the world. But there are so many things which you have to take into account on a regional level, and it's very difficult to point out all the very details in a single report. Nevertheless, you might know that we also have been participants and responsible for the numerics of the global roadmap for the global cement and concrete sector. The measures are all, of course, somehow the same, or I think similar. But as you will see, the implementation, like in your case here in Australia, is very, very specific on your situation. And that is the reason why we have been assigned, or what we have been asked, to deliver this report, which of course we did with great pleasure, I have to say. Now we have the full value chain here, and yes, you will see that the decarbonization pathways, they cover the whole value chain. Of course, we start in cement and in clinker production, but also the question of cement grinding, and the question how much a clinker can be in cement in future, in order to make the cements as CO2 efficient as possible. And the same is for concrete. The question is how much of the STMs like fly ash, slag, or limestone, or in the future calcium and clay, can be in concrete to make concrete as CO2 efficient as possible. And of course, and this is, I think, a focus that SmartCrete also particularly covers, the question, how can concrete be used efficiently in construction for offices, for buildings, for housings, and for infrastructure, of course. And at the end, of course, the question is, how can concrete be recycled? How can also at recycling, the effect of what we call recarbonization, the question of absorbing CO2 by concrete can also be taken into account. So this is the full value chain. And as I said before, it's the first time, I would say, in the history, at least in our sector, in the cement sector, that we are not able to deal with such a challenge, as an industry alone. So we need to really cooperate along the value chain. And I have to say that the experience that we had with the many workshops and video conferences that we did, with all those involved in the value chain, really clearly showed there's a strong willingness to work together. And I think that such a report, the work on such a report, which is the outcome of this kind of early discussions along the value chain can be the point, to really a stimulating point to go further. And I'm very sure that based on what you have delivered and that we compiled in this pathway, this is a report for pathways, can be an excellent ground for implementation to become net zero by 2050. And this is all based on the fact that cement and concrete will be needed in the future. I mean, we need to build. Yeah, there is a need for infrastructure, need for housing and for offices, no doubt. And in your specific case in Australia, for different reasons, the expectation is that there is needs for a 40% growth in construction demand. Yeah, that has to do with population growth, for example, and it has also to do with macroeconomic figures. So that was an input also into this report. So the whole pathways are also based on the fact that there's still a need for construction. And I have to say that there's no serious replacement to that degree that it's needed for construction for cement and concrete. So this underlines, that cement and concrete and construction still have a bright future. And it's in our hands, to make this future net zero when it comes to CO2. And you will see that it's possible once you all work together, or we work all together on a global scale or in the regions where we are working in. Now, let me just draw your attention to the beginning of the value chain, which of course is the cement production. And the cement production is, of course, when it comes to direct emissions here, the source for the CO2, the embedded CO2 along the value chain. And as you all know, we have an issue here in cement making, which is different from many other industrial sectors, or in particular different from the power sector. Of course, we need high temperatures to burn our limestone and clay into what is called clinker. And you know that clinker is the power horse in cement. Clinker is the ingredient, the main constituent in cement that gives strength to cement once it's hardened, and then of course to concrete. And it's absolutely needed in cement. Now, the fact is that clinker burning depends on, as I said, on raw materials, in particular limestone, and the recipe is fixed. There's no way to change the recipe that has chemical and reasons which are part of the mineralogy of clinker. And from the limestone we have, and limestone as you know, is calcium carbonate. We have to extract the calcium oxide, and that releases CO2. So that we have two sources of CO2 from our clinker production, which is namely the process CO2, as we call it, from the decarbonization of the limestone, and there is CO2 from burning the fuels. Yeah. So taking those two as such, you could roughly say 2/3, 1/3. That is the fraction. And on top, of course, we have indirect CO2 emissions, and the experts among you, knowing how to deal with this in the CO2 balance sheets, they know that we are talking about scope 2 and scope 3 emissions. So we have covered also here the scope 2 emissions here from the electricity production. We need electricity to run our processes, in particular for grinding our materials. This, of course, is indirect CO2, but because we need quite a bit of electrical energy, it was suggested, and I think for good reasons, to also cover this here in the report. And then we covered the transport from our materials, cement and concrete, to the customers, just to underline, that there is also a focus to be put on in the time to come to cover these CO2 emissions when we talk about net zero CO2 at the end by 2050 of our value chain. Now, looking from an industry point of view, what are the key issues for success? And there was very good discussions that we had here. And the question was always raised, how can we successfully transform the full value chain? And of course, when you start from cement making and concrete making, and you ask yourself, what are the main levers, I should say, the main pathways, yeah? And then the first thing is to lower the clinker factor. And I think that it's clear, based on the fact that clinker, as I said before, at the very beginning of our value chain is the origin of the direct emissions from the limestone and from the fuels. So as less clinker you have in cement, you could say, as less CO2 I have embedded in the subsequent part of the value chain, which is true. On the other hand, there is always the question, how much clinker do I need in my cement? Cement without clinker is impossible. So, and of course, these are two extremes. And the question is, what can be optimized? And I have to say that it's not only the clinker factor in cement, but it's also the clinker factor in concrete. And Australia has a long and a very good transition to use, these what we call supplementary cementitious materials. These are materials that can substitute clinker. So Australia has a long track record and a very good tradition in using these SCMs in cement, but also in concrete. So the overall clinker factor, as we call it, is already quite good in the Australian cement and concrete sector. Nevertheless, there's always, of course, the question, how can we further optimize the clinker factor? And there are technical issues, of course, and Christoph will come to some of them, a little bit later in the presentation. But there also, of course, the framework is needed, the regulatory framework to allow this, to allow these cements to be used in concrete and to allow these concretes to be used in construction. So that's something that has to be adapted. And when you implement on an Australian level all these measures, all these pathways, the strong focus will be on the regulatory framework to facilitate this. And that also has to do with the standardization. So it's not only the legal framework, but also the standardization framework, because quite a bit of these building codes, they also take it, as you know better than me, take advantage of the standardization. And standardization also, of course, has to reflect these new cements, new cement composition, but also the new technology that is going to be applied in concrete. As important is that there is a push to market. It's push and pull on the market. It's not enough that cement and concrete with lower CO2 as of today is available. It must also find its way to market. And I can tell you, and it is an experience which you are going to make, which you're having already today, but in many other parts of the world, is that procurement in many cases is not addressing this yet. It's not addressing this yet to the degree that would be needed in order to have a certain market pull for these more CO2 efficient cement and concretes. And that also has to do with standards that can be referenced in, for example, in procurement, but it also has to do with, for example, the municipalities, the public authorities, which are in many parts, and it's also the case of the world, is also the case in Australia, which are responsible for quite a bit of public procurement. Yeah, so they could be crucial, in setting schemes in which the pull for these materials on the market can be even better found in procurement, because public procurement is always an example for procurement in other sectors, other parts of the value chain as well. And of course, there's much more. There's a context for approaching the different pathways, and we will come back to this. And at the end, summarizing what else is needed here. Now, I'm not going to read all the numbers for the various pathways, but as you can see here, and later on, of course, in the full report, there are many pathways. They all fit together, and you can clearly see when you go into the details of these pathways, there it's very important that the whole value chain works together. Many of these pathways are not focused only on a very small part of the value chain. Know that it covers everything. And let me just guide you through these pathways. Of course, zero emission electricity and transport, it's clear that also these sectors, power producers and the transport sector, they have the same ambition as us. They also would like to be net zero by 2050, and it can be expected that, of course, electricity and transport will be net zero CO2 by 2050. And already today, cement producers, concrete producers, for example, they try to source electricity with a lower CO2 emission per megawatt hour. And then I think that's important, for you today here, and I know that most of you are, from this part of the value chain and from the academia. The innovation to design and concrete and construction, and Christoph will have a couple of slides later on this. This is very important, that there's still room to to focus on innovation in design and construction, to use cement and concrete more efficiently in buildings and in infrastructure. And this goes hand in hand with the innovation in concrete. The third pathway, I should say here, further innovation in concrete. Christoph will have a few words on this later on. But it also takes into account the question, how do we deal in the future with SCMs? What are the SCMs, the supplementary cementitious materials in the future, when, for example, fly ash might not be new fly ash, not be produced to the degree as it is today, and when, you know, if the steel sector, for example, who is now providing slag, granulated blast furnace slag as an SCM, they also have to decarbonize their value chain. So something is going to happen there as well. And the question is, what are the new cementitious materials in the future? And I have to say that limestone here will play a very important role, but also other new materials like the calcined clays. They all are materials that can contribute to the strength development of concrete, for example, but they can also contribute to the overall performance in concrete. And there's quite a bit of experience available, but as you will see later, there's also, you know, of course, quite a bit of need for research. And I think there are these CRC, like you have excellent experience with in Australia, in particular, SmartCrete, that can play a dominant role, of course, in this. This goes along with new CO2 efficient cement. The same question is, you know, what are the SCMs that can be used in cement in the time to come? Again, the question, you know, what are the SCMs of the future? And it's definitely the case that limestone will play a much bigger role in the time to come, but also, as I said, calcined clay. It's a new material, you know, in our value chain, but it's well known and proven, and, you know, in other sectors. So there's quite a bit of development possible here. Now, when it comes to the fuels being used in our value chain, particularly in clinker production, even if although it's only 1/3 of our emissions, it's really worth to focus on these emissions. And there's a long tradition in our industry to use selected and pre-treated alternative fuels. They tend to have a lower CO2 footprint, and in particular, when they have a high degree of biomass. And there's a great potential, in particular in your country, to take advantage of this and not to landfill certain waste, but to use them energetically. Another thing is to substitute today's fuels like natural gas and predominantly coal by green hydrogen. And it's good to see that the overall approach in Australia, of course, is, you know, to build up a hydrogen infrastructure, which we call green here. That means hydrogen that goes along without CO2 emissions. Once it is available, there's a high potential, a good potential also to use hydrogen to a certain degree in cement plant. Now, the account of concrete to uptake CO2, I mean, many of you are concrete experts, and you know that we have recarbonation of concrete, which is well known, and we have to take it into account when we talk about the coverage of concrete to protect the reinforcement. Yeah, that is well known. But it's also, you know, the fact that concrete as such, you know, is if you look at this, you know, can be seen as a CO2 sink. And it was always a question to what degree concrete, you know, can absorb CO2. It's of course difficult. It depends on the type of concrete. It depends on its specific surface, and you name it. And it's interesting to see that there are quite a bit of research projects have been concluded, and even the IPC, that is the International Panel of Climate Change under the United Nations framework, has addressed this. And a substantial part, you know, of the let's call the original CO2 being emitted from the decarbonization of the limestone is reabsorbed at a later stage. And we might even, and that is one of the innovation areas that we suggest, you know, it might even be that we can accelerate this, that we can enhance this recarbonation. And the question, of course, is how can that be taken into account, you know, describing the CO2 from the overall value chain. Now, we have accounted here 20% of the original CO2 emission from the process, which is in agreement with the international approach at this pathway. Now, the remaining CO2, and there will be remaining, that the value chain will not be able to fully go to net zero CO2 by 2050 with the measures, with the pathways I've just described. There is still the need to capture the remaining CO2. That means, to capture the CO2 at the point of emission, that means at the stack of the cement plant. And then the question is what to do with the CO2. First thing, of course, is you can store it. You can bring it back into depleted oil wells and gas fields. There's a long tradition also in your country, in the oil and gas sector. It's proven technology. The other thing is there anything that we can do with the CO2 to reconvert it to something useful? We call it a CCU, carbon capture and utilization. And as you may know, of course, CO2 is a very stable molecule because it has released all its energy because, as it's the end product of combustion, for example. So in order to make something useful out of it, of course, you have to re-inject, you have to give energy back to it. And that, of course, has to be CO2-free energy. Now, this slide is not a slide I'm going to explain in detail, but it's only, it's a figure out from the report, which clearly shows that under each of these pathways, there's a set of measures, that has been suggested by you in the various workshops that we have been putting together here. And it's now on you, to ask yourself, what are the measures and to what degree can we implement this when you set up a full engagement plan for the whole value chain in Australia. Now, having said this, I will hand over to Christoph to give a few thoughts on the innovations for design and construction, which is basically the concrete part. And I've understood that most of you here in the audience have a strong focus on concrete and its application in construction. And of course, you being a participant at universities, you might also be maybe interested in this. Christoph, I hand over to you, please.
Yes, thank you, Martin. And also from my side, good afternoon, everybody. Yes, indeed. Designers and architects play a crucial role in the design and construction process. So they can make very strong decisions in the beginning of a project with regard to contribute to the decarbonization and to resource efficiency. And they can also take very strong decisions not to contribute to decarbonization and resource efficiency. And therefore, we have highlighted that in the beginning of the process, they are in a role to take the first decisions. And they can take decisions with regard to the design and the construction of the building. And we have seen it within the discussion for all the levers and measures along the value chain, that there are always low-hanging fruits which can take them into consideration in daily business immediately. And there are other things that have to be developed in the coming years. For all the things which have to be developed, we made some proposals for innovation areas, for research and development. So when we start with the low-hanging fruits, so with the things that can already take into consideration, of course, a designer can try to avoid an over-dimensioning of components. It came up in the discussion with your experts, and I assume this is not only the case in Australia, that for the sake of simplicity, sometimes we use the same concrete for certain types of component in one building, and sometimes it's not necessary to have such a high quality of the concrete or such a high grade of the concrete. So a more differentiated selection of the concrete grade is a very simple option that can be taken already today. Then the partners in the value chain can discuss together, and they should discuss together, to what time the strength of concrete is really needed. Is it always necessary to have the strength already after 28 days? Sometimes it makes sense just to assess the concrete strength at a later age. And we, especially when we think about cements and concrete with a lower clinker content and a higher amount of SCM, for example, you know that in most of the cases, then the strength development of the concrete is slower than with an ordinary Portland cement. And therefore, it makes sense if all the partners are aware of the fact that we have a slower concrete, which needs sufficient curing and these things, then it can make sense to have the assessment of the strengths at a later age. So there are other technologies which are already well known. For example, hollow core slabs. We have learned here in Europe or in Germany, for example, that maybe we underestimate the potential of these technology, and maybe you can also try to start the discussion in Australia to what extent these kind of technologies would in the end really save concrete for the same results can be taken more into consideration. So we assume that in the coming years, designers and architects more than today will have to rethink their design with the aim of lifetime extension, with the aim of make it easier to repair and to use the building and the components. And in the end, maybe we need new tools to design really for decarbonation and resource efficiency. And therefore, we made a proposal for an innovation area in this field. And when we look to the next slide, the same applies more or less with regard to the concrete technology. Also there, you as concrete specialists, you know about the option of packing density optimization and of the optimization of aggregate grading. The question is, do we always today in daily business use these potentials as much as possible in lowering the binder content in the concrete? And I would assume that in daily business, the answer is not always. So we can be better also in this field. The experts of the Australian concrete sector, they reported that sometimes there is still potential in a better forecast on the demand of concrete and the adaptation of truck sizes. There seemed to be some potential with regard to a change from dry mix plants to wet mix plants, which is of course not something that can be done just tomorrow, but then that might be a point of discussion for your implementation plan in Australia in the coming months and years. And then a further topic is, and that is also discussed not only in Australia, but also all over the world, and in many committees dealing with concrete, there is always a question of the descriptive approach versus the performance approach. Sometimes there seems to be a contradiction. I think this is not the case. Also, a concrete which is made under the descriptive approach, of course, has a certain performance. But sometimes, of course, description makes a system not really flexible. And what will be important in the future is to have an appropriate balance between these two approaches. And it has to be discussed, what is the performance we need for a certain application? Sometimes strength is enough together with good fresh concrete performance. And sometimes you need sufficient durability of a higher grade with regard to chloride, with regard to free salt. So it depends. And therefore also for this discussion and for this field, we proposed an innovation area to agree in the end with all stakeholders with regard to performance procedures and performance criteria. So when we come to the next slide, this is the use of the SCMs in concrete. Martin already mentioned this. This is a lever and a measure which has already a long tradition in Australia, as well as in other countries. We have a good tradition in using GGBFS and also fly ash. And Martin already mentioned that the steel sector also will have to decarbonize. So the question is to what extent GGBFS will be available in the future. In our report, we assumed that the amounts as they are today will still be available also in the future. With regard to fly ash, we've learned that a lot of stockpile fly ash is available in Australia. Of course, it's not all available as such. Most of it might need processing, especially the ponded one, which might have a high chloride content, and therefore also we proposed a research area for that. Then the limestone, which is the basic material, the base material for the clinker production, it can also be used in an unburned condition. Of course, it has its technical limitations, but we know also from our own research that there are still potentials which are not used today. And calcined clay, also available in sufficient quantities in Australia. So what is needed is, to some extent, a broader database on cement and concrete with all these materials. And once you have this database, then you have to come together with all the stakeholders to change or to modify the standards and the building codes to make use of the benefits of these SCMs in concrete and in cement. And so, when I say cement, we also implemented some proposals for new CO2 efficient cements. You see them on the next slide. We are quite confident that it will be possible and should be possible to use cements with a higher limestone content than you have it today for certain applications, especially for the applications where mainly strength is the main performance criteria. So for a lot of concrete which is used for indoor components, it's mainly strength and good fresh concrete properties. So if carbonation is not an issue, if freeze-thaw is not an issue, if chloride is not an issue, for sure you can use cements with a higher limestone content. If you need a better performance also with regard to the density of the concrete, you can combine the materials. You can combine, for example, limestone with calcined clay. A very prominent project, which is, I think, well known all over the world, is the LC3 projects with clinker content of 50%, and then, for example, 30% of calcined clay and 20% of limestone. But we are quite confident that it's also possible to go even lower with the clinker content. And here in Europe, we had the discussion, and we will have also a new cement standard taking into consideration such cements with, for example, up to 45% of fly ash, calcined clay, or GGBS, together with 20% of limestone. Of course, also here you have to adapt the standards and the application rules to be able to use these cements, and maybe it comes to a more differentiated use of these cements, because these cements will not be cements for one size fits all. Especially when it comes to limestones, there are certain limitations which makes it necessary to focus on a certain application, maybe a little bit more than in the future. So that were some examples from these pathways along the value chain. And I think now we have to come to the question, what are the prerequisites for a success decarbonation, Martin? Martin?
I'm sorry, I have to unmute here. Okay, there indeed, a couple of measures which are needed to make this transition happen. I mean, we have heard so far about the various pathways, but even in the Q&As, it becomes clear, that it's not just happening, because we want it or because technology is there. No, that needs some framework, and it's a framework, I think, that we all have to work together is with. Then, of course, there are also some things which are not really under our control, like the electricity grid that has to be decarbonized by 2050. But it's great to see that that some of the cement producers are already now trying to source electricity with a lower CO2 emission per megawatt hour as compared to the average. Yeah, the same applies to the decarbonization of transport. There's something that's not really under our control. When I say our control, I mean the industry's control here. But on the other hand, of course, it's a push and pull. If we ask for this, if we source this, I think it's also a little bit the chicken and egg. If somebody asks for this, I think a development will also take place. And I think that construction sector can be a facilitator when it comes to electricity and transport. But also when it comes to the CO2 from our fuels, there must be sufficient zero carbon fuels being available, in particular biomass and hydrogen. There's a huge potential in Australia which is not exploited yet. There is of course always a question of transport distances and so on, but there is still something that can be done, and that needs also the waste management legislation, of course, which takes this into account, and a certain hydrogen plan to be implemented to make also hydrogen being available for the cement production as a fuel. And finally, of course, carbon capture for cement technology for cement production must be technically deployable. I have to say that in principle, most of the technologies when it comes to carbon capture are at a state, and we talk here about technology readiness level, where they can be scaled up to industrial scale. But it needs, at least at the very first beginning, it needs support. It needs support through funding. It needs also support from the government when it comes to CO2 infrastructure, for example. So it's not easy to really implement this from an industry point of view, because there we clearly need to strongly cooperate. And that is not only the case in your country, it's all over the world. We have to strongly cooperate with society, but also with the policymakers to make this really happen. I have to say that Australia has a very good infrastructure for CO2 transport. You have huge experience and traditions in transporting and dealing with gases, for example, and to store and utilize it. So I think there's a huge field in which this can CCUS, as we call it, can be successfully be implemented. Now, the product and design standards allow for lower carbon cements and formulations. I think that has been mentioned before, and it must be adopted by the market. I have seen, while Christoph was giving his slides, there was a question, what is the balance between market push and pull? Yeah, so I think this is a question that you will have to answer in the course of the implementation. Now, there's probably not an easy answer to this, but I think for sure I know, and I could really feel this, the strong commitment from the cement and concrete producers to go for lower CO2 cements and concrete, and they will do all to bring these new products on the market with less clinker at the end in their products. But it requires, of course, as I said before, that these products are bought by the customers, and that they are also part of public procurement. So I think there's something that there's no one size fits all for solution for this. I think you will find a solution there in your country, but I can already see in our country, if there's a willingness from the whole value chain, all of a sudden there are opportunities to bring those cements on the market. And if I may say, because there was also a question in the Q&A, and I just jump into this, the question on the time that takes to develop new standards. Again, a very valid point. But again, my feeling is here, if the whole value chain is really willing, to accelerate standardization, and to make sure that it's well supported by good research results, I think standardization can also be faster than standardization that we are used to time-wise. Last point here, recarbonation during the concrete life cycle stage really has to be taken into account. It's not only the balancing factor of CO2 here, but I think we can really take advantage of this natural recarbonation of concrete. And in some degrees, I think we can even find solutions to enhance it actively. Now, we have been asked, not only to put these pathways together, but also the question was raised, how can the Australian cement and concrete sector together with the whole supply chain, but also with the academia, how can they address the specific items. And there's, of course, there's always need for research. And we have come up with these innovation areas here that are fully described in the report. And I think we don't have time to go into the details here. But since you are from the value chain and from academia, I would like to address on those ones here which specifically go for concrete, and Christoph will highlight them. The great situation that we could sense, in Australia is that you have an excellent research infrastructure. There's a strong and good cooperation, in the CRCs, within the sector, but also, with all of those downstream, the value chain, and in particular with universities in the academic world. So I think that's something that you can build on. And we believe that research has just two aspects. First of all, is of course you come to good results, that facilitates a certain process. But the other thing is you work together on something. That means it's a transformative research that happens. And again, building on the tradition that you have in research in Australia, I think that's an excellent starting point to also address those here. This is a suggestion from our side, and of course it's up to you now to implement this and also to talk to funding organizations to make sure that you have sufficient funds to go through this. Christoph, I hand over to you to explain the ones I've highlighted here. Please, Christoph.
Yes, just a few details with regard to the 6 innovation areas which have been suggested with regard to the supply chain here. So I saw in the Q&A and in the chat that there is a question how to come forward, how to deal with the performance approach. And this is a good question. From my experience, one of the crucial things is that the first thing, if several cement and concrete and construction people in one room talk about performance, they sometimes have in mind total different things. So the first thing is you have to define what is performance for certain applications, which might seem trivial, but sometimes it's a very important thing. And then the next thing is that, of course, you have lab performance on one hand side, especially when it comes to durability, and performance in the building on the other hand side. And therefore, the proposal is that you really should start with all the stakeholders together, a joint research to come to a clearer figure, what is the correlation between lab performance and performance in the building. And then you can end up with a kind of performance approach where all the stakeholders together are happy with. I think this is very important because this is a baseline then for a database on the properties of low carbon cement and concrete. A very simple example is the carbonation of concrete. I think the concrete specialists, they all know that the carbonation depth is totally different in a concrete using a CEM1, a Portland cement, or a concrete using with a higher amount of slag, for example. But what does it mean in the end for the performance in the field? So you need a lot of data for that, and it would be very helpful to start to gather more of this data. This is here is the second innovation area. Then you have seen, or we have learned in the process of setting up this report that a lot of fly ash is stockpiled in Australia, but it cannot be taken, or it seems that most of it cannot be taken as such as a concrete addition or as a main constituent in cement. So therefore, it needs further research, and also therefore we proposed here an innovation area of the beneficiation of fly ash, especially with regard to the focus on the chloride content. Then when you look to the literature, when you look to all the things that are going on with regard to the additive manufacturing and the digitization, 3D printing, we see that around the world, these production methods are gaining maturity. What we do not know already is what is the contribution to decarbonization and resource efficiency. I'm quite sure that 3D printing is a very good solution if you really have a lack of skilled workers. It's a very good solution in general for the quality. But what is the contribution to decarbonization and resource efficiency? Will we really save CO2 and materials by implementing these techniques? And therefore, already here, also here, we propose an innovation area. Then you have seen that we see a big potential with regard, or a huge potential with regard to the design as such. And therefore, also, we are quite sure that some further research work is needed here to really be able to have design tools which a designer can use to design for decarbonization and resource efficiency. Do all the approaches the designer used today for calculating and for developing the design, is it really the optimized thing with regard to saving CO2 versus the technical performance? I think, or we think, that a lot of work can be done also there to be able in the end to deal with all the benefits that can be taken there. And last but not least, the recarbonation issue. When you look to the IPCC report, you see for the first time ever that on this high level, cement-based materials are recognized as a CO2 sink. Personally, I was a little bit surprised that in the IPCC report, the view is really optimistic. They say that 50% of the process emission can be taken up. I think under very good conditions, under certain assumptions, that might be the case. Nevertheless, for the time being, here in our report, Martin has mentioned it, we took the conservative approach with only 20%. But of course, it makes sense to dive deeper into this issue, not only with regard to the natural uptake of CO2 in the building phase and with regard to the recycling materials, but also with the question of the active CO2 treatment technologies. And I also saw this question here in the chat. There are already experiences that you can treat fresh concrete with CO2 and you can just save cement by that. So this should also be further elaborated here to have the full picture in the end. So that was a quick overview of some of the details of the innovation area. Here on the last slide, of course, you see where you can access the whole report. There is also a summary. Of course, we would like, once again, thank you to all the contributors, which includes the financial ones, but also all the very good discussions we had with all the stakeholders in the different workshops. Now we are more than happy to discuss with you and answer your questions. Thank you.
Thank you, Christoph and Martin. Zoe, we have a lot of questions that have been put through. Can I ask you to just sort of start to go through them? We've got quite a few. I'm not even sure we're going to get through them all, but I'll defer to you on that. Thanks, Zoe.
Absolutely. Thank you, Matt. I think there's a wide range of questions, so probably focus on a lot of the panelists. I may hop around and just ask a few of the questions. But I think the first question that was actually popped up was by Craig. Process emissions from the conversion of calcium carbonate is well understood. Did the report also consider the use of pre-calcined material, feedstock or stock, and various SEMs for clinker manufacture? And this could be an area for reductions. I wonder, Martin, if you're the right one to assist us with that question.
Yeah, with pleasure. Yeah, we have taken this into account, but only to a very, very small percentage. It's always a question, what is decarbonated raw material? Where do you gain it from? And there's good experience, for example, with the crushed concrete sand, for example. Once it's not recarbonated yet. So that is one source, and there are other sources from other industries. So I think that's also something that can be covered in one of these innovation areas to ask, what are the right materials. But it's a valid question, and we have seen that, on the global average, you can have a few % of CO2 savings when it comes to the process emissions. Yeah, so very good question, and thanks for this.
Thank you, Martin. Craig, I hope that's a satisfactory answer. I'm told I've got a bit of an echo, so I'm going to just make Jackie, possibly you could take over and I'll just relocate, see if I can find the source of my echo. He's not there. Righto. I'll ask another question and then move on. I hope you can hear me. Next question from David Hocking. Was there a view on how to create a pull versus push environment for low carbon concrete, lower carbon concrete?
Yeah, I think I tried to answer this in the course of the presentation. It's a very, very valid question, and I think that there's experience in each of the regions, and of course you have to make this kind of implementation in Australia as well. And I said, there's a strong commitment from the cement and concrete producers to produce these kind of cement and concretes with a continuously lower CO2 footprint, and of course that they have to be bought, and public procurement plays a role, of course, here. The willingness of the stakeholders, to put this on their internal agenda. Yeah, it's that the CO2 must become important, in the whole value chain. And MECLA, for example, is an organization that we talk to, and not only in the course of the whole exercise, but also with the presentation. There's a Green Building Council of Australia, which might be important. So these are all partners which could help, to facilitate this push-pull effect. Yeah, there's no single and simple answer to this, but I think you have to figure out what is the best. Most important thing is, and we could sense this, from all the discussion, is the willingness across the whole value chain. I think that's the first thing, information and willingness along the whole value chain to make sure that you would really address CO2 much better in the time to come. That is the biggest facilitator, I would say.
Thank you. I'm hoping that I've addressed my issue with the echo. I'm going to jump to a question from Greg van Rooyen. It's actually a question that I've wanted to answer for a very long time. Given Australia's predominantly dry mix, I'm assuming the net benefit of the wet batch comes from cement production through mixer efficiency. Is there any data on this? Perhaps you can give us the European perspective if you have it.
Christoph, I think you will take over this question, please.
I have problems here with to understand it. Is it the question with regard to the fly ash or?
Oh, dry mix, wet mix, Christoph.
Dry mix, wet mix, yes.
It's an experience that we have, and
yes. It became quite obvious in the discussion with the experts here in Australia that a shift from a dry mix to wet mix is really an option to save some of the cement with regard to that you have a higher efficiency in mixing the concrete. You know that here, for example, in Europe, in Germany, most of the concrete is wet mixed. So I think we already made this journey, and from the discussion, we are quite confident that these step from dry mix to wet mix would have a very positive effect. And in the full report, we had also a link to some literature with regard to this topic. Yeah.
Well, I can maybe add that was something that was brought up, by the expert that we talked to, because there's very little experience in this shift in our country, and of course it has also regional reasons, that the tradition is like it is, but it was addressed, and therefore we put this also here in the report, very tentatively, of course, and it's up to you now, of course, to decide to what degree that might be able to be implemented in all these engagement plans that you are going to work out now.
Okay, thank you, Martin. I've just had to take over some of this because Zoe's having some technical issues. I'm amazed at how we can do this with people all over the place. So we rely on technology, and then technology doesn't feed us too well. I'm hoping you can hear me all right. There is a question that I think most interesting one from Craig Heydrich. Harvesting of coal combustion products from storage is increasingly being undertaken in EU and North America. Whilst there is some processing costs, much of the published literature suggests that the material is of good, if not better quality. Can the authors comment on their EU experience with respect to harvesting fly ash and coal combustion products?
Maybe Christoph, I could try to answer this. There's in Europe, I would say it's very little experience, because all the fly ash, and we are talking about fly ash from black coal, yeah. So the silicious fly ash, yeah. That is all immediately used, yeah, for good reasons, because there's a tradition in this, and but I think in countries like Australia or in the United States, there are these, and in China also, India too, we noticed from the discussion that we had on the global level. So there are many countries in which there's good silicious fly ash stockpiled. Now, there are two issues. I mean, I should not tell you, because you're probably better concrete experts than us here, but in your specific
case. Absolutely not. Please.
There are two things, the TOC, I mean, the loss of ignition, yeah, that's one thing. And, that there is, there are these technologies to separate these components, which have a higher and lower LOI, this. So that's two. It takes energy, it takes cost. Yeah, it costs something, and of course you have to transport and ship the fly ash. So that overall, is something. But then we learned that some of the fly ash, or most of the fly ash, I have to say, or coal combustion products in Australia, are ponded for the reason to eliminate fugitive dust. Yeah, which is very good approach, and very good from an environmental point of view, from dust point of view, I would say. But the question is there a potential to retrieve this or not? And this is a question, I think, to that degree that is not answered yet. And therefore, we were asked, and that it's obviously, to have an innovation area on this. I mean, you have to address this and to try to figure out under which condition, which fly ash can be retrieved for potential use as an STM. So there's no simple answer to this. The only answer is, it takes an effort to process it, and it takes costs, of course, But the question is, cost-wise, what are the various measures, that can contribute.
So in the EU, is there a lot of experience with respect to harvesting ash from ponds or harvesting ash from repositories? Because we do in Australia have a lot of repository material as well.
No, in the EU not. Yeah, there's no silicious fly ash, being taken from stockpiles. And I'm talking about stockpiles where the fly ash has been sitting for years. Yeah, I'm not talking about stockpiles, smaller ones. There's a big experience in the United States, yeah, for sure. Right. There's growing experience when it comes to lignite, but we call it calcareous fly ash, but I think that is not the case in Australia.
Right,
that you can take advantage.
Okay. We have a question from David Hocking on standards and specifications. Standards and specifications can take time to adopt innovation. That's very true. A strategy or collaborative approach to move to performance versus prescriptive approaches will be necessary. Are there views on how we best achieve this? I know in my life as a civil engineering consultant, this is something we do with all the time, but from your experience in the EU, how do people handle innovation, performance, prescription?
Maybe I can try to answer. Martin mentioned the main point is you have to use the momentum we have now, that people are more and more aware of the fact that we have to change. We have to do this transition. I have seen this here in Germany. I think almost 2 years ago, good colleagues from the construction industry told me, "Oh, it's not my problem that you in the cement industry have a CO2 issue." Now they totally changed their mind. So there's another mood in all the committees now that people say, "Okay, we have to do it together." And I think this momentum, we have to do it together, and to have it in mind that the only way is to solve it together. That maybe and hopefully will lead to the fact that the experience we had in the past, that it's a long journey, it takes sometimes years, that this will speed up, and hopefully this will also be the case in Australia. So use the momentum now, sit together with all the stakeholders along the value chain, and then I'm quite confident things can change much quicker than in the past.
And are you finding that your innovation strategy, like with the new information that's coming through, is that fitting into German and European standards quicker than it has been in the past in our concrete area?
To be honest, yes, I have good experience in the last month. We are just preparing a new concrete standard, and I mentioned that we prepared a new part of the cement standard as well. And in this new part of the cement standard, we defined a new cement type, which we call CEM2C, which is 50% of clinker and 30% of GGBS and 20% of limestone. And we did some research on the properties of these cements and concrete using these cements. And just on the basis of this research, I was able to make new application rules in the concrete standard. So the answer is yes. It just went from our research into the building code. So that is what I mean with people change their behavior, understanding that now it's not time for discussing it for 10 years or 15 years, but to do it now. Yeah.
And on that,
very good experience now. Yeah.
And on that note, there is a most interesting question from Basil Ben. The target 2050 is 29 years away, and many in the audience will not be around. Certainly, you're right, Basil, I certainly will be around. If we are serious about decarbonisation of the cement industry, then we need to set 10-year targets to work to monitor and revise the plan so that the 2050 target is achievable. Look, can I just get some thoughts from certainly Chris or Martin on that? And Warren, can I put you on the spot as well once that happens, because I'd be interested in your perspective as well locally. Christoph, maybe? So if we're looking at a 2050 target, should we be doing something more quicker, I suppose?
I think the purpose of this report was, to show up the pathways, and now you have to build up the engagement plan and Yeah, and of course the engagement plan is also, the milestones. That's so to say. What are the milestones? And there was a suggestion, that this report should be at least, reviewed every 5 years, to make sure that the implementation plan has taken this into account. Yeah, but you are fully right. We have to use the momentum now and not to lose time, which we cannot make up for in the 40s, for sure.
Yeah. And so look, I'd love to take credit, but this is Basil's question, and I think what you're saying is endorsing the fact that just the fact that we've got a 2050 target doesn't mean we wait. We've really got to start working now and really engaging in everything. Warren, do you have any thought on that in terms of just local perspective?
Yeah, I think the local perspective really is, and this is what Martin was talking about, that we really need to get on with the job now. And a lot of these innovation areas will take quite a long time to realise. And, the challenge of the report is that it's shown, or it's designed what it can look like in 2050. But I think we do need to consider that intermediate targets to just plan and to get the momentum shifted from what's been fairly piecemeal in the approach. And there's nothing like a target to energize the sector, if you like.
Right. Okay. Thank you. And an interesting question from David Hocking about low carbon concrete. There's certainly a lot of discussion about low carbon concrete. We're not even quite sure what it is. It's about pull and push, but the question I have, is it low carbon concrete or low carbon structures? Christoph, Martin, we'd be interested in your thoughts on that.
Yeah, maybe I can say something to that. Maybe some of you know CRC, the Concrete Sustainability Council, which is a scheme to certify sustainable concrete. And what they have just under development is also a new tool dealing with the CO2 issue. And this is, I think, in the end, trying to answer this question: what is a low carbon concrete? They will have within the CO2 module different levels of carbon footprints for concrete. They will have a benchmark, a regional benchmark, because it makes no sense to have one benchmark on a global level. So they will have regional benchmarks. There are regional program holders. And then when you then compare your concrete with this benchmark, you will be able to get a certification that you are 10%, 20%, 30% better than the benchmark. And this certification scheme and this labeling can then be used by the concrete producer, and can also, of course, be used by contractors and by designers to say, okay, I want a concrete of level 2 or level 3, which means a concrete with a lower CO2 footprint. This is on the concrete level. Of course, in the end, you also have to go to the building level to make definitions there. And I can only tell you here from our German experience, we have a certification scheme here in Germany also for certification of buildings, sustainable buildings. And I just recently published a report benchmarking the amount of CO2 per square meter of the building. So that also gives you a feeling, where are we today in conventional buildings, and where can we go in the future? So I think we have to discuss it on the concrete level per cubic meter, but not only per cubic meter, but per cubic meter and strength class, because you have to take into consideration the performance of the concrete. And then, of course, you also have to go to the next level to define some benchmarks, for example, per square meter of a building.
And Christoph, do you think that it's more like a driven from the cubic meter of concrete level, or do you look at it as a developers trying to build a building, or infrastructure authorities trying to build a tunnel, and you say, okay, how efficient is my tunnel? Because I suppose you can come at it both ways. I mean, hopefully you meet in the middle, but in the last 15, 20 years in Australia, and we discussed this before, I've really found it all about, a lot of pressure on the supply industry to sort of come up with innovations in terms of concrete, which I think is great. But how does that translate, for example, to your measure of, embodied energy per square meter in a building, which I think is much more powerful? How has that been taken up in Europe? Is that concept now spreading? I know from our office in London that there's a lot of work going on in terms of sustainability and design. But yeah, I'd just be interested in your experience in terms of how they've taken that up.
I think when I look to the situation here in Germany, I think the infrastructure sector is a little bit behind the building sector. The certification scheme I just mentioned is for offices, for buildings. It's not for bridges or tunnels. What we sometimes see is that the ministry, which is responsible for the tunnels and the bridges, they of course are claiming that we have to build more sustainable. And if we come with our solutions with CO2 efficient cements and concrete, then on a lower level where the decision has been taken, they say, oh no, I do not want to have these cements and concrete because I'm not sure about the performance, and will these concrete be able to last for 100 years? So there is a certain gap in this field. So I think for the time being, the momentum has been a little bit higher in the building sector than in the infrastructure sector. but hopefully also in the infrastructure sector, they will mention that also in their field, maybe there's still potential for improvement.
Okay, thank you. An interesting question from Mike Ritchie. We've been, for Warren and Zoe, we've been in meetings all day, and glass is a massive issue. Question, can you discuss the potential of residual glass in concrete, and particularly the relationship between glass size and ASR? At what particle size does glass add to concrete strength, and is it realistic substitute for some proportion of cement and concrete making? Now, that's a very big question, as there's been a lot of experience or a lot of literature done in this area in Australia and various parts that we certainly discussed today. But in Germany, do you, and in Europe, do you have focus on glass? Do you have the glass going into concrete? What's the experience there with glass?
We do not have it in daily business. We had approaches to use glass as an aggregate, for example. I think the ASR issue is of importance there, and I've seen both. I've seen results which were really good, where we did this ASR test and everything was fine, and I did the opposite. So I would say it depends. It can work. You have to test it, so when you hear in Germany, for example, you try to get a technical approval for such an approach, you have to do an ASR test, and if it's okay, then you can go for it, and if not, then you should not try to use it.
And I guess that's the experience with pretty much all, like all products that go into when you've got the building sector and the infrastructure sector, they're pretty well regulated and things, certainly in Australia. I suppose that's the same approach you'd use for any new material coming in, geopolymer or anything like that. Do you in Germany and Europe use a lot of geopolymer?
Yeah, it depends how you define a geopolymer. If we define it as a slag or a fly ash, which is activated by alkalis, the answer is not on a broad scale. There is one company coming from Australia which came to Europe for technical approval. I think they already got it. And maybe there are also some special fields of application where they already implemented their products, but not on a broad scale. And in the end, of course, if the basis for the geopolymer is fly ash or GGBS, of course, the fly ash and the GGBS can only be used once. Huh? We can use it in cement or without activation in concrete, or we can try to activate it. And so the answer is not on a broad scale. It's there, but more as a niche product.
Okay. Warren, can I just bring you in here? We're sort of getting close to time. I might just get you to sort of give your feel, because I know you've done a lot of work in the glass space. And then perhaps, Warren, could I ask you then to just maybe round this off and sort of close the session and go from there, because I think we're about time.
Yeah, thanks very much, Dak. Firstly, just to explore the application of glass a bit more, I would say that there are volumes of research literature around the application of glass, and it's really the adjustment of specifications to allow the use of that material that needs to be explored, rather than, I think, the science of incorporating it into concrete. So as you said, we've gone through quite a few project proposals today that actually explored some of those things, some of those properties of glass and concrete. And perhaps we've rejected some of those in that they've gone back to first principles. It seems to be quite a mature research topic. So the next step with a lot of these, as it is with a lot of these things, is the application and the specification adjustment to allow the use of glass and other materials. So at SmartCrete, some of the projects we've got underway is looking at a variety of materials that may be able to be used and use some of the circular economy applications of concrete to dispose or to use the materials, building on, again, the knowledge that we've built up over years around slag and fly ash, for instance, and their incorporation into concrete. And with that, yes, we're a couple of minutes before the end. So firstly, I'd like to thank both Martin and Christoph for their time. It's quite early in the morning for them, too early for a beer, apparently. So we hope they can enjoy a nice warm coffee after this. I'm also told it's quite cool in Germany at this time of year. Again, like to thank them for all their work in the report, and we will honour your work, hopefully, by applying the outcomes that are in that report. I'd also, again, like to thank Race for 2030 and also the Cement Industry Federation for helping us basically get the report off the ground and get it happening. I think the challenge to us all now is to take the content of the report from a research and innovation area point of view, certainly think about how that can be structured into specific research projects, and then come along to SmartCrete. We've certainly could facilitate that research, and also we have some money that can also help realise the research. I think Martin said it best earlier on in his presentation. He identified in this report the need for innovation and research to realise the ambitions of the report, and also for the transformation of the sector. And SmartCrete is there to assist in that transformative research. So thanks everyone for your attention today. And for those of us in Australia, have a good evening. Thank you all.